So first of all, I would like to thank you to be our distinguished speaker. I would like also to thank the audience for attending this invited talk, which is part of the Mosaic Lab invited talk series. Today's talk is on network analytics and automation in 5G, which is going to be delivered by one former colleague of mine, a very close friend of mine, Konstantinos Samdanis. His short name is Kostas. Kostas currently is working for Nokia. He received his master and Ph.D. degrees from King's College London in 2003 and 2009. He worked for NEC Europe, Heidelberg in Germany. Actually, that's when we met first time. And he worked between 2009 and 2016 as a senior researcher and a broadband standardization specialist. He was involved at that time in different European projects, including the 5G Norma, and did also different standardization activities on mobile backhaul and self-organized networks. From 2016 to 2018, he moved to Huawei Technologies in Munich, taking the role of a principal researcher for 5G networks, where he was involved in strategy and research for 5G architecture and transport networks, being active in a broadband forum and 3GPP system architecture working group and IETF. Since 2019, he has been a research project manager at Nokia Bell Labs in Munich. He's been involved in different standardization activities on 5G core and network management, concentrating on network analytics and automation, which is going to be the focus of today's talk. He's been acting as a delegate in 3GPP SA5. Dr. Samdanis, he has arranged and also authored a book on green communications published by Wiley, and he's been authoring different academic publications, almost 80 academic publications and 40 patent applications. So once again, thank you so much, Kostas, for willing to give this talk, and the floor is yours.
Yeah, thank you very much for the introduction, and thank you very much for inviting me here. It's a pleasure to give this talk, and thank you very much for hosting this event. So you can hear me correctly, right? You can hear me right? My audio is good.
Perfectly at my end.
Okay, great. So my talk is going to be on network analytics and automation in 5G. I am going to concentrate on my talk mostly on the standardization and on the enablers side, and not so much on the algorithmic. And the thing that I'm going to show is mostly the development of standards in 3GPP SA2 and 3GPP SA5. So let's see what this talk is going to be about. So we are going to see in the beginning what is the value of analytics and what is its impact in the network and what benefit it brings for operators. We are going to see an overview of like the network automation, so where analytic is positioned. And then we are going to examine the two paradigms. One, the data analytics on the 5G core, and the other one, the data analytics on the management plane. Then we are going to dig into the enablers of analytics and show things like how a consumer can ask analytics, how the analytic function can collect information, how the analytic function can report the information to the consumer. And finally, we are going to conclude and show like some conclusions and some further thoughts. So what's the impact of automation and analytics? The main areas that impact is, and the main value that it brings for operators is the fact that it can provide like a special service for like third parties. That's one of the first like benefit. It can provide assurance, it can help to provide assurance, service assurance for third parties, make sure QoE, and make sure that they can enable special applications like vehicular applications that they are so demanding in terms of quality of service, quality of experience. It can introduce new applications. It can introduce applications for related to automation services. It can enable Industry 4. It can enable energy, smart grid services, smart city services, and also smart home services. So it can play a key role on the automation loop. The fourth one that it can bring is efficient and rapid network troubleshooting. Network operators, they deal with fault, with alarms, and this kind of alarms, it might create even more alarms and even more alarms. So the role of analytics and automation is key for this area, for troubleshooting, is key to be able to do things fast and efficient. And the fourth area, of course, is big data. Analytics can play a key role here to enable completely like new services for operators, data services that they can also like in the future be able to sell. Now with this, let's see, like before going further, what is network analytics? Now, this is a Nokia view. Like analytics, it's a means that they can turn data into knowledge. And we can use this thing to improve the network and the business performance. This is something that comes like, this is the Nokia like view, what is the network analytics. And explaining like what network analytic it can bring. It can bring either statistics to a consumer. Statistics is data from the past, assuming that a future event will have like a similar behavior. It can bring prediction in terms of like forecasting, so it can forecast an event, and it can bring recommendations, so it can recommend certain options to the consumer. A key thing behind these different flavors of analytics is the fact that the analytic service, it can provide you the information without providing you the decision. The decision is up to the consumer. So the consumer receives this type of information, even the recommendation options, and is up to the consumer to make the final decision. So this is like, you know, a key thing for analytics. Analytics can be applied in the 5G core. So it can enhance the control plane and the user experience. It can be applied on the management and orchestration. It can assist processes like how to scale up, how to scale out, how to perform root cause analysis. It can assist the radio for fast allocation, scheduling, and short-term tasks. And it can assist the applications. It can provide like a reconfiguration of a codec. It can assist V2X to be able to provide information what would be the best level of automation when a car is moving on the road. So automation and analytics, it can be applied in different parts and different levels inside the network. It can be applied from like a network element, like a base station, and it can take a form of a SON function, which is something that it is known now for many years. Like I think like a lot of people came across SON functions. It can be applied on a domain level. So it can be on a domain level on the management plane. It can take care of like the management of the core network. It can take the management of the radio network. And it can also be applied on a particular like plane, like the control plane for the core network. So the focus would be like only there. It can also be applied across different domains. So it can assist how resources are allocated across the radio and across the core network. And it can also play a key role on the business automation, being able to analyze and map how a communication service needs to be deployed inside the network. A key thing also here is the fact that analytics, it's a part of a greater loop. It's called the ODA loop. It can get information from like a data collection like entity. So you can see here on the figure that I have, The green one, you can see that the analytics is get fed from the data collection. It can provide the insight to the intelligence. The intelligence is the consumer that makes a decision, and the decision is being pushed to an orchestrator and controller to be able to perform a certain act on this. So automation, in summary, it can be applied into different levels, and it can also be a part of a greater loop of automation. Now, looking on the analytics service itself, here we can see how we can decompose it, into very basic functionalities that it can either be located separate, it can be combined in different ways, and it can provide a means of a flexibility of how analytic services can be deployed in the network. Now, this information, I took it from ITUT. So in ITUT, there is a special group on analytics, so you can get more information from there. The main thing here is the fact that an analytic service can be decomposed in the elements that you can see in this slide here. So it can be decomposed into the sources that it can provide the data for the analytics. The sources, it provides the data to some kind of entity that it is the collector. The collector, it gets information from different type of sources. This type of sources, it can be on a certain domain, for example, on the radio, it can be on the transport, it can be on the core. The collector feeds the preprocessor. The preprocessor, what it's doing is aggregating the data, and it's also formatting, preparing the data, because the different sources, it might have different formats. So the preprocessor aggregates, formats, prepare the data for feeding the analytics model. The model itself, it's the logic, it's the algorithm where the analytics is performed. And once a result is produced, then the analytic model, it feeds the distributor, where the distributor is responsible for identifying and forwarding the information to the different sinks. The sinks are the consumers of the analytics. Now, there are two key things behind this process. One is a policy. So you can have a policy configured there to govern how information is collected, how information is distributed. And you can also have a network analytic orchestrator, that the orchestrator is responsible for creating this, in a way, service chain. Because what we are having here is some kind of a service chain, some kind of a pipeline, where all these different elements, they are linked one to another in order to create an analytic service. Here in the figure, you can see that the analytic service can be applied in the network directly. You can see here that all these different processes, they can be on different domains, and one can feed the other from different domains, and you can create a chain like that. The other thing that you can see in this figure is the fact that this type of analytic service, it can also be a part of a sandbox. So it can be a part of some kind of a simulation process that it can simulate how things would be in the network, and it can assist also in this type of way. Now, with that, we can move on now on the 3GPP space, and we can look on the two different analytic functions there. The first one is on the 5G core network. And here we can see I have circled the analytic function there, which is called the network data analytic function. It's the NWDAF. And we can see the NWDAF with respect to other network functions in the service-based architecture of the 5G core here. And we can see here what are the different sources of data of the NWDAF. The service-based architecture, it enables the analytic function to get different input from different network functions. These network functions here are the different network functions that you can see in this figure here. It can be information from the AMF, from the SMF, even from the UPF, from the PCF. It can also get information from application functions, either they are untrusted functions that you can get information through the NEF, or it could be trusted application functions when you can get input information directly. You can also get information from repositories. These repositories here, I have the example of the user data repository. We can also have like information from the network data repository. And of course, you can get information from the OEM. Now, collecting like this information, the NWDAF here is doing all the processes that we saw before. It collects the information, it processes the information. It has an analytics model inside the NWDAF. That the analytics model, it can be proprietary model. And it has also a mechanism that it can distribute the output of the analytics to the different network functions that they have subscribed, to untrusted application functions, to trusted application functions, or it can also feed the OEM. Now, here you can see a list of the different use cases that SA2 has considered. As said before, the majority of the use cases for the 5G core, they are UE-centered analytics. So there are analytics that they focus on the UE mobility, how predict or provide statistics on mobility of particular like UEs or group of UEs. It can assist in providing UE communication patterns, provide service experience. So it can provide information about like the QoE per flow, taking into consideration a particular MOS. It can provide information like security information about an abnormal behavior or a misbehaving UE, for example, like devices like IoT devices that they are placed in a certain location and they are misplaced, or they are producing much more information than what is expected. It can be identified by an analytic function, or devices that they are connecting and reconnecting and they are misbehaving and there is something wrong. It can be identified by the UE abnormal behavior analytics. Analytics in the core can also provide co-sustainability. This is an analytics service that is very important for vehicular. So this provides an insight of the likelihood of changing a quality of service. So once you are having a vehicle that is going down the road, then seeing what is the likelihood when the vehicle is handing over from one base station to the other base station, what is the likelihood of a cost change is very, very important for the V2X applications. Then it can provide a user data congestion. What is the likelihood of having a congestion in the UE, considering like the data plane as well as the control plane. And then it can also assist on network analytics. Network analytics, it can be important for application functions, since the core network through the network exposure function can communicate with application functions and can assist the application function by also providing network analytics like network performance, network slice load, network function load. It can assist application function to take care about the user experience and the user behavior. A key point here is the fact that the core network, it gets the main insight regarding the network analytics from the OEM. So the OEM is the main data collection point, and that provides the network analytics to the core network in order to enable a network insight. Moving now on the management plane. Analytics, it can also play a key role on the management plane. On the management plane, you see here how analytics is positioned. So in the management plane, there is the management data analytic function. A key thing about the management plane in general in 5G is the fact that the management plane, they focus more on defining interfaces. So you can see here MDAS, it's an interface. And the main thing is the fact that on the management plane, the standardization do not concentrate on boxes, but they concentrate on interfaces. So because a management box can have a lot of proprietary like functions and it is outside the standardization scope. That's why the main focus on standardization on the management plane is on the interfaces. Here we can see that the management plane analytics, it can get information from different other management services. This analytic information input, it can be performance measurements, it can be KPIs, it can be trace information, MTT information. It can also be fault measurements and alarms. It can also get input from the NWDAF, which is like the core network. And the main input that it can get from the core network is the service experience and the QoE. It can process like this different like input information in order to provide analytics to certain consumers. And these consumers, it can be other management functions and services. It can be core network functions like the NWDAF, or it can be any other network functions in the core network. It can be a SON function, centralized SON function. It can be an optimization tool, or it can be also a human operator. So there's a wide variety of an analytic consumer on the management plane. Here you can see the different management plane analytics. There are much more than this, but these are like, the main categories. There are analytics that they are focusing on resource management, and this is about like predicting resources. It can provide like certain like operations like feasibility check. For example, you can say like if it is feasible to admit a new slice or not based on the prediction of resources in your network. It can play a key role on the SLA assurance. So it can play a key role on making sure and providing the insight to make sure that the end-to-end delay is always fulfilled in all the different subdomains, and is able to provide like root cause analysis for the SLS assurance, for the latency, for the jitter, for fault reasons. And also like it can assist like network slice load, where the load is like hitting a point where it's like becoming an overload, to be able to trigger a network reconfiguration, or even in cases where the load is like much lower, to be able to save resources. Analytics, it can play a key role on SON. So it can enable different like SON, traditional SON function. It can play a key role on coverage issue, to be able to do root cause analysis on different coverage problems. It can play a key role on mobility management for handover optimization, or selecting the best mobility mechanism depending on the use case and the experience that is needed. It can assist energy saving functions. It can predict the load to be able to activate, deactivate certain run and core network function. And it can also play a key role on SON coordination to do conflict prevention and resolution. And finally, another key thing is security. So we can predict, there is a key use case on how you can predict the VNF security, do root cause analysis, and provide like prevention suggestions. So with this, like now in our mind, we are gonna move on seeing what are the key analytic enablers. A main thing here is like we should understand that analytics is not a single function inside the network. Analytics, it can be different like functions and different services, either in the core network or in the management plane. And these analytic functions, it can be per particular operation. You can have like an analytics taking care of mobility, or an analytic function taking care only of a service experience, or a combination. You can have like an analytic with respect to a particular region, a geographical region. So you can say like, I don't know, Munich, it can be like a certain analytic like function, and Nuremberg, it could be like, a different one. An analytic function can also be positioned on a certain like domain. So you can have like a different analytic function for the core, different analytic functions for the radio. Or analytic function, it can also have like different capabilities. So it can have the capability to report at different times. It can have like, a different computational capabilities. For example, you can have like different algorithms that they are running behind like certain analytic like functions. Or it can have like different filtering capabilities. For example, like filtering capabilities, it could be like a report after a certain threshold, or report after a user is doing something. So with this, like the main message here is the fact, like, analytics, we can have like a different like implementation, like flavors of analytics. And this, it brings the question how you can discover them, because a certain consumer might need like a particular analytic for a certain operation, for a certain like region with certain capabilities. So the question here, how we can discover them. For the management plane, 3GPP, they have identified certain like discovery mechanisms where a management service can query, assuming that it knows the IP address of another of the analytic phase service. It can query directly, and it can say, well, what is your capabilities? And then the analytic function can report back. And then the management service, it can make up its mind whether these are the kind of like services that it needs or not. A different mechanism for discovery exists on the 5G core. In the 5G core, this kind of like information regarding the names, IDs of analytics, operation regions, and capabilities, they are stored in the NRF. So when you do an NRF query in the 5G core, you can get back from the NRF the type of analytics that they are available, and they match your request to the NRF and your criteria. And an open issue here that it hasn't been resolved yet is like, how can you do a cross-domain analytics? How can you do like, how can you discover analytics from your 5G core to your management plane, or from your management plane to the 5G core? This is something that is an open issue currently, since the two different like planes, they are handled like separately. Now, what would be like, an analytic like, service, what would it need in order to be like, identified in this discovery like, process? It would need a name. It would need an ID that it can describe its operation. It would need a scope, a scope of operation to identify the region where it's operating. And then you would need like, to specify to this analytic service, what would be like the target of your operation? What are you looking for? Are you looking for getting analytics for particular users, for a particular user? Are you looking to get like analytics for a particular area, for a particular application, and so forth? And the final thing is that you need to provide to analytics is like filtering. When filtering in terms of timing, scheduling of like what you would expect from this analytics, and certain rules on when to compute and when you need a particular report. Now, this is an overview of like the analytic process. So we can see here the network analytic producer, which is like the analytic function here. We can see like in the middle of this function is like the analytics model. We can have different flavors of analytic models. We can have ML analytics model, AI analytic models, reinforcement learning, rule-based, or whatever else you need. The producer of analytics, it needs some kind of a mechanism to handle subscriptions or requests from the consumers. So being able like to understand what the consumer is asking. the analytics producer need also to have like some kind of like a mechanism to be able to collect information. And this mechanism, it can be like mechanisms that it can continuously collect information. So on a constant basis, your producer is getting information from different sources and is having the analytic services ready to be produced. Or it can have a mechanism to instantiate what type of like information and which type of data sources it needs to communicate with in order to get this analytics. So on the data collection like side, there are two different like ways you can do it. And then the analytic producer also needs like some kind of like a reporting, some kind of like a mechanism to report once the analytic services are produced towards like, the consumer part. Of course, another thing that it is very, very important here is dealing with the analytics like model. Dealing with the analytics model, it can be handled like outside the analytic producer or the analytic function. And here there is a need to have some kind of like an analytics model orchestrator. The analytic model orchestrator is able to decide when a retraining, for example, is needed, when your model is not performing well. And it can tell this thing by getting like information from different data sources. So it can get like information like training information, validation information from the different data sources. It can also get like feedback from the consumer. So getting feedback from the consumer, it can have like an understanding and it can decide when your model is not behaving as is expected. It can take care of the life cycle management of like the model. It can perform like tasks for training, retraining, replace model, model sharing, and so forth. And this type of processes. Now, just to provide you like an overview of like the two main like enablers of like analytics, how you can request analytics and see like specific information that a consumer needs to provide. As said before, a main thing on the consumer to request analytics is to be able to identify like the analytics name or the ID, indicate what is the desired service, right? The other thing is like to identify what type of analytics it needs. Do you need statistics, predictions, or recommendation? And then provide a scheduling time. I'm interested to get analytics from starting this time for this duration. And then to provide what is the target object. I am interested to get analytics for a UE, UEs, a group of UEs, a particular area of interest, an application, a certain session. Then you can provide information about the accuracy. The accuracy, it applies into particular target objects. So the accuracy, you can have low, medium, or high accuracy. For example, you can say, well, I am interested in this group of UEs, but, well, I don't care about getting 100% information from all the UEs, but like 50% of this information from these UEs, it would be good enough to create this analytics. So your accuracy, you can tune the percentage of like the target objects that you need to take into account. This could be the target objects, it could be UEs. The target objects, it could be base stations. So you can say, if I get information from 80% of the base stations regarding like this analytic service, I'm happy. So this is what you can tune by accuracy. And then you can introduce like filtering conditions. You can say, please send me analytics if the loads surpass a certain threshold, if a UE enters a certain area, if a UE start moves. So you can specify when and under which conditions you need analytics. And then you can specify the reporting method. You can say, I am interested to get a certain file at a certain point of time, or I am interested to get the streaming. Streaming means like, I need analytics all the time. So whenever there is a change on your calculations, please let me know. So this is like a service that you can get like from streaming. And then you can have like the reporting. You can have like, in the reporting, you can have like the feasibility. Feasibility is like until when you would need like a report. If the report is not there at the time that you are asking it, or to indicate if you need a report immediately. And this is like some information about like how the report would look like. the report, it needs to have like the name, so the consumer knows that, okay, this report is about this analytic service. It needs to have like the analytics type. This report contains statistics or predictions or recommendations. This report has a timestamp, so this report was produced at this particular time, and it is valid for the next, I don't know, 20 minutes. So the consumer knows when to use it and when this report is valid. It needs to contain the target object, so you can say this report, it contains this group of UEs, or this report contains this area of interest, or whatever. It contains also information about the confidence degree. It provides like an insight about like the accuracy, the expected accuracy of like a prediction, or the expected accuracy of a statistics. And then it contains the reporting itself. Like it can contain like data information, for example, like prediction of a load. It can contain information about the root cause. You can say like to a consumer, well, your, I don't know, tilt has a problem, and then the consumer can like resolve like this kind of problem. And the reporting can also have like information about expiration information, which means about information when the whole analytic service reporting is going to expire. So this is like to enable the consumer, to let the consumer know, well, you're going to receive 3 more reports related to this analytic service. If you want more, please subscribe more. Please ask for more analytics. So this is just a reminder for the consumer to renew the subscription. So with this, I will conclude here, and I will let people like bring questions and have like a discussion. The main points to take here is the fact, like, you know, on the analytics enablers, key things is the discovery, analytics discovery as a process, the data collection and the request reporting. The thing that is also important is to understand that analytics can be on the core network management plane, but there is a need of like interaction. There is a need to have like some kind of like flexibility of like bringing things like together in terms of like data, and also in terms of like the intelligence. And I'd just like to raise some questions here. Main open points is like to think is how we can do like this decomposition and flexible composition of these analytic services, keeping in mind that an analytic service can decompose into the parts that we saw like in the presentation. And the main thing like to consider is if we want to share this information, especially to external like entities, how we are going to do it, under which conditions we should do it, what about anonymity of the data, how we are going to handle like information that it is important for the operator. So with this, I would like to pause here and take questions and open a discussion. Thank you very much.